Welcome to another edition of The Explainer. If you've ever felt like your security protocols are just acting as this giant roadblock to actually getting things done, you are absolutely going to love the material we're unpacking today. For a long time, traditional IT security basically meant control through restriction. The logic was super simple, right? If you can prevent access, you prevent risk. But as we shift over to the cloud, well, that outdated security by restriction model is actually breaking things. So today, we're exploring a massive, real game changer of a shift toward a cloud-native approach that actually enables speed and innovation rather than stifling it. Okay, let's dive into this. Here's a quick roadmap of what we'll be covering. First up, we'll look at the problem with no. Then we'll break down the three pillars: confidentiality, integrity, and availability. And finally, we'll wrap up with how to make security an enabler.
Section 1. The problem with no, and exactly why traditional security logic totally fails in modern environments.
To really figure out how to secure the cloud, we kind of have to understand why the old perimeter-based security logic completely falls flat for modern development. Traditional IT was incredibly static. You had these clear physical perimeters, predictable human users, and these big monolithic systems. But the modern cloud? It's a completely different beast. It's entirely API-driven. Workloads are distributed all over the place across different regions and platforms. Identities are dynamic, and your applications literally depend on continuous machine-to-machine access. In a world where developers are deploying code multiple times a day and apps are constantly talking to dozens of microservices, trying to apply a static, perimeter-based mindset is honestly like trying to enforce a speed limit on a rocket ship using a stop sign. It just doesn't work. And that brings us to this incredibly powerful realization from our source material. In this environment, saying no by default isn't security, it's operational drag that teams will route around. I just want to pause for a second and let that sink in. When security reflexively says no, it doesn't actually create safety, it just creates friction. And what happens when you create friction? Well, human nature takes over. When security teams constantly say no to access requests, the delivery of the product can't just stop, right? So what do the developers do? They bypass the controls, they find a workaround, and suddenly, boom, your organization sees a massive spike in shadow IT. It's almost comical in a way. By trying to lock everything down way too tightly, security teams inadvertently push developers right into the shadows, and ultimately, they lose their visibility and influence because they're just viewed as being completely incompatible with delivery. Moving on to Section 2, confidentiality, the right access. This is all about shifting from restriction to minimal contextual access. Now, what's really interesting about this first pillar of our modernized triad is how clearly the paradigm has shifted here. The old thinking was really simple. Don't grant access unless it's absolutely necessary. But the cloud reality? It dictates that access is the very lifeblood of the system. Just think about microservices communicating with each other, or CI/CD pipelines, automation workflows. None of these function without access. Old restriction models literally break modern automation. Let's look at a highly practical scenario. Think about a standard DevOps pipeline. It needs access to deploy applications, read secrets, update infrastructure, the whole shebang. If you apply the old model and just block this access outright, the impact is immediate and severe. Deployments fail. You suffer delayed releases, you experience outages while scrambling to fix things, and you miss crucial business commitments. The system basically breaks because the security control fundamentally misunderstood how the system operates. So we have to redefine confidentiality for the cloud era. It means controlled, contextual, minimal access. We're talking about leveraging least privilege, utilizing short-lived credentials, and implementing identity-aware role-based controls. It's access granted for the absolute shortest time possible, and crucially, it's continuously reassessed. We aren't saying no. We are saying yes, but only exactly what you need, exactly when you need it.
Section 3. Integrity. Protecting system behavior. We're moving from protecting static records to verifying actions.
Okay, moving right along to integrity. Under the old thinking, this just meant ensuring data was not modified. You just locked the database down, right? But the cloud reality is that data is continuously being written, updated, and processed by completely legitimate automated systems. Because data is always dynamically changing, the real threat isn't just data modification itself, it's unauthorized actions being taken by valid identities, whether those are human users or automated workloads. Let me give you a terrifyingly common practical scenario. Imagine an application workload that legitimately has permission to update database records. Now, if that workload gets compromised by a bad actor, it can wreak absolute havoc. And the really scary part?
It performs those destructive changes using entirely legitimate permissions. Traditional integrity checks wouldn't stop it at all because the identity technically has the right to modify the data.
Therefore, modern integrity requires a behavioral approach. Integrity in the cloud means we must validate every single request. We have to constantly monitor behavior patterns and detect anomalies early. It's no longer just about asking, does this workload have permission? It's about asking, is this workload behaving normally for what it usually does? We are verifying actions, not just protecting static records.
Which brings us to Section 4, Availability, ensuring resilient access. This is the shift from basic uptime to controlled accessibility.
That leads us right into our final pillar, availability. We are moving away from the basic, old-school concept of just uptime and stepping into the realm of ensuring resilient, controlled accessibility. The old thinking on availability was wonderfully simple, honestly. Just keep the servers up and running. But the cloud reality is vastly more complex. Modern systems are distributed, dynamic, auto-scaled. In this environment, availability is not just about a server having power. It's about ensuring secure, predictable access under constantly changing loads and shifting risk landscapes. It is controlled accessibility. Here is a scenario that brilliantly illustrates why this matters so much. Imagine your security system blocks API calls because of an overly strict, rigid rule. The underlying infrastructure is perfectly healthy. The servers are humming along. But because the API access is blocked, the application is effectively dead in the water. So, an overly rigid security rule has literally just created a self-inflicted outage. To fix this, we have to redefine availability in the cloud. Instead of using blanket blocks that just kill the application, we use smart throttling. We use adaptive security policies that actually respond to context, and we implement failover-aware security design. It's all about maintaining secure, uninterrupted access so the business can keep functioning smoothly, even when anomalies pop up.
Section 5, Security as an Enabler. Let's talk about enabling speed with guardrails and visibility.
And this brings us to our final point. Security must become an enabler. Once we modernize the CII Triad, security stops being the department of no and transforms into a tool that enables the business to move at incredible speed safely. What does this look like in practice? Well, it's a rapid-fire series of modern protocols. First, identity-centric security, always asking exactly who is accessing and what their specific context is. Next, just-in-time access, granting access only at the exact moment it's needed and automatically revoking it immediately after. And crucially, continuous verification, meaning there is absolutely zero implicit trust. Every single request is validated every single time. Building right on top of that, we also rely heavily on policy-based controls. We're moving away from slow manual approvals and really embracing automated enforcement that scales with the cloud. And finally, comprehensive observability and monitoring. We track all actions and use sophisticated tools to spot abnormal behavior across the entire ecosystem. So the crucial point is this: security isn't about denying access. Honestly, it never really was, but especially not in the cloud. It's about meticulously controlling how access is granted, how it's used, how it's monitored, and how it's revoked. The extremes simply do not work. If you block access, the business grinds to a halt. If you allow everything, your risk explodes. And that leaves us with this final thought to take back to your own teams. If blocking access stops the business and allowing everything explodes your risk, how will you build yes, but under control in your own cloud architecture? Think about how you can implement these guardrails to turn your security from a blocker into your biggest enabler. Thank you so much for joining me on this explainer. Keep learning, keep building securely, and I'll catch you next time.